Time to go further into other technologies that are used to make blockchain as secure and robust as it is made out to be. Digital signature is one of them. A digital signature is a mathematical technique used to validate the authenticity and integrity of a message, software, or a digital document. A valid digital signature gives a recipient a compelling reason to believe that the message was created by a known sender and that the message was not altered in transit. Digital signatures are a standard element of most cryptographic protocol suites. They are commonly used for software distribution, financial transactions, contract management software, and in other cases where it is important to detect forgery or tampering. They can provide the added assurance of evidence of origin, identity, and status of an electronic document, transaction, or a message, and can acknowledge informed consent by a signer. In many countries, including the United States, digital signatures are considered legally binding in the same way as traditional document signatures. So, how do these digital signatures work? Digital signatures are based on public key cryptography, also known as asymmetric cryptography. Using a public key algorithm such as RSA, one can generate two keys that are mathematically linked, one private and one public, that are two mutually authenticating cryptographic keys, also known as key pair. The individual or entity who is creating the digital signature uses their own private key to encrypt signature related data, and the only way to decrypt that data is with the signer's public key. Digital signature technology requires all the parties to trust that the individual creating the signature has been able to keep their own private key secret. If one loses the private key, then the whole network can be compromised. A digital signature scheme typically consists of three algorithms. First, a key generation algorithm that selects a private key uniformly at random from a set of possible private keys. The algorithm outputs the private key and the corresponding public key. Second, a signing algorithm that, given a message and a private key, produces a signature. And last, a signature verifying algorithm that, given the message, public key, and signature, either accepts or rejects the message claim to authenticity. Digital signatures require two main properties. First, the authenticity of a signature generated from a fixed message and fixed private key can be verified by using the corresponding public key. And the second property, it should be computationally infeasible to generate a valid signature for a party without knowing that party's private key. Let us now look at how to create these digital signatures. To create a digital signature, signing software creates a one-way hash of the electronic data that is to be signed. The private key is then used to encrypt the hash. The encrypted hash, along with other information such as the hashing algorithm, is the digital signature of that signee. The reason for encrypting the hash instead of the entire message or document is that a hash function can convert an arbitrary input into a fixed length value, which is usually much shorter. This saves time as hashing is much faster than signing. The value of a hash is unique to the hash data. Any change in the data, even a change in the single character, will result in a different value. This attribute enables others to validate the integrity of the data by using the signer's public key to decrypt the hash. If the decrypted hash matches a second computed hash of the same data, it proves that the data has not been changed since it was signed. But in case the two hashes do not match, the data has been tampered with in some way, hinting a compromise to its integrity, or the signature was created with a private key that does not correspond to the public key presented by the signer, which is an issue with authentication anyway. One of the important property of digital signature is non-repudiation. And what is it? A digital signature can be used with any kind of message, whether it is encrypted or not. This, in turn, helps the receiver to be sure of the sender's identity and that the message arrived intact. Digital signatures make it difficult for the signer to deny having signed something, assuming their private key has not been compromised, as the digital signature is unique to both the document and the signer, and it binds them together. This property is called non-repudiation. Digital signatures are not to be confused with digital certificates. Both are different from each other. A digital certificate is an electronic document that contains the digital signature of the issuing certificate authority. It binds together a public key with an identity and can be used to verify that a public key belongs to the particular person or entity. Most modern email programs support the use of digital signatures and digital certificates, making it easy to sign any outgoing emails and validate digitally signed incoming messages. Digital signatures are also used extensively to provide proof of authenticity, data integrity, and non-repudiation of communications and transactions conducted over the internet. So, are there any classes of digital signatures? Answer is yes. What are they? There are three different classes of digital signatures. Class 1. Class 1 signatures are validated based only on an email ID and username and provide a basic level of security. They are used in environments with a low risk of data compromise and cannot be used for legal business documents. Class 2. Class 2 digital signatures authenticate a signee's identity against a pre-verified database. Class 2 digital signatures are used in environments where the risks and consequences of data compromise are moderate. Some examples are e-filing of tax documents including income tax returns and goods and service tax returns. Class 3. They are the highest level of digital signatures. Class 3 signatures require a person or organization to present in front of a certifying authority to prove their identity before signing. Class 3 digital signatures are used for e-auctions, e-tendering, e-ticketing, court filings, and in other environments where threats to data or the consequences of security failure are high. Let us understand some of the uses of digital signatures. Industries use digital signature technology to streamline processes and improve document integrity. Some of the industries that use digital signature include government, where digital signatures are used by governments worldwide for a variety of uses including public and private laws, congressional bills, processing tax returns, verifying business to government transactions, ratifying laws, and managing contracts. Most government entities must adhere to strict laws, regulations, and standards when using digital signatures. Next is healthcare. Digital signatures are used in the healthcare industry to improve the efficiency of treatment and administrative processes, to strengthen data security for e-prescribing and hospital admissions. It is important to know that the use of digital signatures in healthcare must comply with the Health Insurance Portability and Accountability Act of 1996, which is also known as HIPAA, HIPAA. Manufacturing is another domain that uses digital signatures heavily. They use digital signatures to speed up processes like product design, quality assurance, and manufacturing enhancements. It is also used in marketing and sales. The use of digital signatures in manufacturing is governed by the International Organization for Standardization, also known as ISO, and the National Institute of Standards and Technologies, also known as NIST. Can financial services be left behind? Of course not. The financial sector uses digital signatures for contracts, paperless banking, loan processing, insurance documentation, mortgages, and more. We all know how heavily the financial sector is regulated, especially after 2008 financial crisis. This sector uses digital signatures with careful attention to the regulations and guidance put forth by the Electronic Signatures in Global and National Commerce Act, also known as eSign Act, the state UETA regulations, the Consumer Financial Protection Bureau, and the Federal Financial Institutions Examination Council. Next, we look at the security features and benefits of the digital signatures. Security features embedded in a digital signatures ensure that a document is not altered and that signatures are legitimate. So what are those features? PINs, passwords, and codes. They are used to authenticate and verify a signee's identity and approve their signature. Email username and password are most common examples where they are used. Timestamping provides the date and time of a signature. Timestamping is useful when the timing of a digital signature is critical, such as stock trades, lottery ticket issuance, and legal proceedings. Asymmetric cryptography. This employs a public key algorithm that includes private and public key encryption or authentication. We have learned about this form of cryptography when we studied the cryptography in blockchain. Checksum. A long string of letters and numbers that represent the sum of the correct digits in a piece of digital data, against which comparisons can be made to detect errors or changes. Checksum acts as a data fingerprint. Cyclic redundancy checking, or in short CRC. An error detecting code and verification feature used in digital networks and storage devices